Hello, we're going to be talking about root functions today. This is going to be a two-part video. Part 1 will be more about the function side, and part 2 will be about solving equations with the root, like a square root or a cube root. Let's start with the functions. Even root functions first. They're kind of separated into two categories. A square root, or any even root, can only operate on a positive number. So if I wanted to write that out in general with some symbols, okay, the inside of the square root is usually called the argument. We're saying that that argument has to turn out to be a positive number greater than or equal to 0. Let's graph the square root function. I know we've done this before, but just to give you an idea of how this works. So when we graph the square root function, I need to pick numbers that are 0 or greater because I'm just plugging that number in for x. I'm not doing any additional work with that number. And that's why this one starts at 0. If I had anything else inside of the square root, I might have to adjust the starting point. Then any number after 0 would be okay to plug in. It's going to be convenient and something I can do maybe in my head if I choose perfect squares like 1, 4, and 9. So I take the square root of those, I get 0, 1, 2, and 3 because I use those perfect squares. And so the shape sort of looks like a half a parabola on its side. Just a half. Okay, the domain and range for the square root function, from left to right, I'm starting with x is 0 and going on to infinity, and I have a point there at 0. From bottom to top, the lowest point is also with a y value of 0 and grows as it goes to the right, so the range also goes from 0 to infinity. We can take a square root function and use this idea that it has to apply to something positive to find the domain. Let's look at an example. This is an example from your book. This one is not a square root. It's a fourth root, but all the even roots act the same. This negative on the outside has no effect on the domain. This affects the range. Okay, and we're just going to talk about the domain for right now. So whatever's on the inside, 2 minus 0.5x, needs to be positive so that I'm able to take the fourth root of whatever number results. So 2 minus 0.5x, I would really prefer that to be greater than or equal to 0 so that I'm able to work with the fourth root. This is the domain. I just need to solve for x now so I can be more specific when I talk about it. So I'm going to subtract the 2 over to the other side. And divide both sides by negative 0.5. Because it is a negative that I'm dividing by, I do have to flip the sign. So I'm going to get x values less than or equal to 4. Any x values 4 or smaller will work in this function and allow me to calculate a y value. I would like to write that in interval notation. If you need to, you can use a number line as a visual aid. So I want to include 4 and everything smaller. So my domain from left to right is going to go from negative infinity up to 4 and including the 4, so square bracket. Okay, and this graph shape would be reflected over the x-axis and I believe reflected over the y-axis. So we get sort of a curve, I don't know where, I guess at 4, right? That looked like that. Well, yeah. Okay. What about odd functions? Odd roots maintain their sign. So if I plug in something negative, I get a negative y value out. If I plug in something positive, I get a positive y value out. And I'm okay to plug in a negative number for an odd root. The reasoning behind that is because if I take an odd number of negative numbers and multiply them together, I'm going to get a negative number. So I can take a cube root, say, of -8 because of this phenomenon. I can't do that with a positive number. I can't do that with an even root, right? Because a negative number cannot be written as an even number of negative parts. I hope that makes sense. Okay, so to graph the cube root, I can use any numbers, positive or negative. 0 is at the center of this shape. Just like before, it's going to be more convenient if I use perfect cubes if I want to do it in my head, but any number is fine. If you wanted to do -2, -1, 1, and 2, those would work with your calculator. I'm going to use perfect cubes because I want to do it in my head. -8 is a perfect cube for this reason. -1 shows the same pattern. 0, 1, and 8 work really well. Then I'm going to take the cube root of those numbers. The cube root of -8 is -2. This would be -1, 0, 1, and +2. Okay, so on the right side, I've got 0, 0, 1, 1. I guess I didn't really think this through. This was 5, 6, 7, 8, 2. Okay, so it is kind of elongated. And then on the other side, I have -1, -1, -8, -2. So it's going to look something like this. Okay. Notice it stretches all the way out. There's no places where, there's no x values that I can't use. There's no y values that I can't get as a result. So the domain is all real numbers, and the range is all real numbers. It's true for this cube root and for any odd root as well. Okay, so let's take an example from your book and kind of do the same thing where we talk about the domain. I also thought we could talk about what this function would look like based on transformations that we've been working with. So we could rewrite this function and factor out the 8 on the inside. Those two things are multiplied. I'm allowed to break up the cube root in terms of multiplication. So I could think of this as the cube root of 8 times the cube root of x minus 3. I already know the cube root of 8. That's 2. So this is really like 2 times the cube root of x minus 3. So I can talk about what this graph would look like. It looks like the cube root graph, which is what we just drew. On the inside, we have this minus 3. So it's shifted to the right by 3. And it also has this 2 on the outside that's being multiplied. So that's a vertical stretch. So it's the same shape. It's been shifted right by 3 and stretched vertically. Are either of those going to do anything to the domain? The answer is no, right? So it's good to have a mental picture of what the graph would look like, but the domain for this cube root is still going to go from negative infinity to infinity. And the same would be true for the range. Okay, a couple other things in this section. One of them talks about how to graph a circle. So I wanted to do that with you by hand. And then I thought we could graph it on the calculator as well. We've talked a little bit about circles here and there, and this is probably good because we're going to have a whole section on circles at the end of the term. But it's good to kind of get your feet wet a little bit. If I wanted to graph the circle by hand, it's good to identify both the center and the radius. So the center is the H and the K. This is like the shifting, and this is the format of the equation that we have for a circle. So the H here would be a 2, and the K here would be a -2. Because of the way the equation of the circle is written, both of the H and the K for the circle look opposite in sign from what we see, because they're now both on the inside, right? The X, the -2, the 2 here is on the inside of the squaring, and the +2 is on the inside of the squaring. And so for that reason, it's opposite of what we would think. Okay, and then the radius. Notice the format has the radius squared. So the radius must be the square root of 4, which is 2, since 4 is 2 squared. So to draw this, I usually put a little X where the center is. That's not really part of the graph, but it is something I want to keep track of, so I mark it. And then from there, the circle is going to stretch out 2 units. So I usually mark the corner points. 2 units on the left, 2 units on the right, 2 up, 2 down, and then I try really hard to draw a good circle that passes through those 4 points. Okay, that's decent, but not perfect, but that's okay. Okay, so if I wanted to make this graph in my calculator, how could I do it? One of the problems that we have is that the circle is not a function. It does not pass the vertical line test. Okay, so I can't graph this whole thing at once because it's not a function. And my calculator, at least in the mode that we're used to using, does not graph non-functions easily. However, I can, it's also, when I'm going to graph with my calculator, I need to type it into the y equals screen. So it's not in that format, so I need to put it into a format where it's solved for y. So let's do that. Okay, so if I wanted to solve for y, I would need to move this whole x minus 2 squared term over to the other side. I think that's a good first step. And then I want to get y by itself, so I'm kind of peeling back the layers. The next layer I need to remove is the square here. So I'm going to take the square root of both sides. Anytime I put the square root into the problem and it's not already there, I need to include the plus or minus. And that's a really key part of what we're doing right now. So the square and the square root are going to cancel each other out. And then I want to get y by itself. So I'm going to subtract 2 over to the other side. Okay, so this is a formula that I could plug into my calculator. Notice the plus or minus. For each x value I put in, I'm going to get 2 y values out. So I need to graph both, the one with the plus, which is going to give me the top half of this circle arc, and the one with the minus, which is going to give me the bottom half of this circle arc. So let's try that out. Here's my calculator. I'm going to go to the y equals screen. I'm going to type in, make sure you use the negative key for this -2. -2 plus square root of 4 minus, it's good to put in the parentheses here, x minus 2 squared, and then close the parentheses. Let's go ahead and graph that. All right, so that gives us the top arc. Let's go back to y equals and graph the bottom. So now for y2, I'm going to arrow down to the next y that I have there, and I'm just going to leave them both in so I can graph them at the same time. Now I'm going to do -2 minus the square root of 4 minus x minus 2 squared, close the parentheses, and I'm going to graph that. That's going to add the bottom arc. Now sometimes these touch and sometimes they don't, so you're just going to have to kind of fill a gap in, all right, and use your imagination, I guess. This one doesn't look perfectly circular. It looks kind of elongated. I think the book talks about putting this in a square window because the screen here is not square. And that's a feature under the zoom. So you can do zoom square, it's number 5. And that will adjust it to look more like a square. And now it'll look more like a circle. Okay, so that's how you can graph a circle, both by hand and on your calculator. Let's take a look at doing the same thing for a horizontal parabola. Okay, to plug this into our calculator, we would need to do the same thing. We would need to solve for y. So let's do that. So we'll subtract 1 over, and we'll apply the square root to both sides. Same thing's true here. I'm putting in the square root. It's not already there, so I need that plus or minus. So when I graph a parabola that's on its side, it's horizontal, it's also not a function because for each x, the plus or minus gives it away. I'm going to get 2 y values. So if I were to graph it by hand, I would need to maybe do these individually. Well, maybe we don't need to, but I'm going to do the positive square root of x minus 1 and then the negative square root of x minus 1. Just so you can see those separately and how they go together. All right, so because of the -1, this is shifted to the right by 1, which means the starting point is no longer at 0, 0. It's going to be moved to the right by 1. So 1 would make a really good starting point because 1 minus 1 is 0, and the square root of 0 is 0. 2 would make a good one because 2 minus 1 is 1, and that's a perfect square. 5 would make a good next point because 5 minus 1 is 4, and 4 is a perfect square. Okay, now it's not essential. You could have done 1, 2, 3. Okay, but if you want to make nice round numbers, these work nicely. So if we plug these or plotted these, we have 1, 0, 2, 1, and 5, 2. This is the top half of the parabola that's on its side. Okay, if I add the negative, the same x values work really well for the same reasons. If I plug in 1, I'm still going to get 0. If I plug in 2, I'm going to get the square root of 1, and then I'm going to apply the negative. So I have -1. If I plug in 5, I'm going to get -2. So this is going to give me the bottom half of this parabola. To do this on my calculator, just like I did for the circle, I would graph both of these so that I could see them together. So let's do that real quick. So I could do the square root of x minus 1. That's going to give me the top half. And then I'm going to add to that, use the negative key, not the subtraction key, or it'll give you an error. Negative square root of x minus 1. And graph that as well. And that will give me the horizontal parabola that I was trying to make. All right, I hope this gave you a good idea about square roots and the functions that we can have derived from them. In the next video, we'll talk about solving equations with square roots. Good luck.